These are the activities for College Algebra Lesson 27. Number 1, find B, the growth or decay factor, R, the constant percent rate, and write an appropriate exponential function P of t. Okay, so the current population of Nigeria is 182,867,960 and has a current annual growth rate of 2.7%. So the interest rate is given as 2.7%. Sorry, the growth rate, percent growth rate is 2.7%, which makes R 0.027. We just changed that to a decimal. B is always 1 plus R, so my growth factor is 1.027. And P of t, my function, is going to be my initial value, or my initial population, 182,867,960 times the growth factor, 1.027, over and over again for t years. Okay, so for B, you drink a cup of coffee containing 200 milligrams of caffeine. The body processes caffeine at the rate of 12.9% per hour. Okay, so your growth rate R is negative 0.129. So you're decreasing the amount of caffeine in your body by 12.9% per hour. So R is negative 0.129. B is always 1 plus R, which comes out to 0.871. And that represents how much caffeine, or what percentage of caffeine, remains in your blood every hour. So 87.1% remains because we took out 12.9%. And then P of t is A times B to the t, so initial value, 200 milligrams, times the B value, 0.871 to the t. There are really only two flavors of graphs of exponential functions of the form f of x equals b to the x. We're going to plot one of each and then fill in the blanks for their general properties. So f of x and g of x, I'm going to fill in the y values for these given x values. F of x is 2 to the x, so 2 to the negative 3, that would be 1 over 2 to the positive 3, or 1/8. 2 to the negative 2 would be 1/4. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the first, 2 squared, and 2 cubed. So let's go ahead and plot those. Negative 3, 1/8, so that's teeny tiny. Negative 2, 1/4. Negative 1, 1/2. 0, 1. 1, 2, oops. 1, 2. 2, 4. And 3, 8. So this is my exponential curve. It's growth because as x goes to infinity, the function is increasing. This is called exponential growth. Because the b value is 2, which is bigger than 1. So 2 is our growth factor. Okay, now let's do g of x, which is 1/2 to the x. So 1/2 to the negative 3, that would be 1/2, 1 over 1/2 to the positive 3, which is 1 over 1/8, which is 8. Okay, and then you could do the same thing for 1/2 to the negative 2, and you would get 4. 1/2 to the negative 1 is 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. 1/2 squared is 1/4, and 1/2 cubed is 1/8. Okay, so we'll plot these, and I have negative 3, 8, negative 2, 4, negative 1, 2, 0, 1, 1/2, 2 1/4, and 3 1/8. Connect those with a nice smooth curve, and this one is exponential decay because as x gets bigger as we move to the right, the y values are decreasing. Okay, so now let's look at each of these graphs separately and fill in some info. So the domain for 2 to the x would be all of the x values that you can plug into this formula or that have a point on this graph, and that is all of them, negative infinity to infinity. And the range, though, is only 0 to infinity. So we're looking at the y values for this graph. This graph does not exist below the x-axis. So the lowest y value is 0. The biggest y value is infinity. But this actually doesn't ever get to 0. 0 acts as an asymptote. So I'm going to do a round bracket on the 0 because it's not included. Is it 1 to 1? Yes, it passes the horizontal line test. Its y-intercept is at 0, 1. It has no x-intercept. It never touches the x-axis. Horizontal asymptote is the x-axis, which is the line y equals 0. And end behavior, as x goes to infinity, f of x grows up towards infinity. And as x goes to negative infinity, the y values are approaching 0. For g of x, the domain is also negative infinity to infinity. The range is also 0 to infinity. Is it 1 to 1? Yes, it passes the horizontal line test. The y-intercept is 0, 1. It has no x-intercepts, never touches the x-axis because it is a horizontal asymptote. And as x goes to infinity, g of x goes to 0. And as x goes to negative infinity, g of x goes to infinity. Okay, so we just graphed 2 to the x and 1/2 to the x by hand. If you put them on the same coordinate plane, it looks like they are reflections of each other over the y-axis. So first, let's label which one is f and which one is g. So we know this because we just did them by hand. This one was f, 2 to the x, and this one was g, 1/2 to the x. The graph of g of x is a transformation of the graph of f of x. Describe this transformation. It's a reflection over the y-axis. So the y-axis acts like a mirror. And if you flip f over that mirror, it would land right on g. So that means that g of x should be f of, to reflect over the y-axis, you would do negative x inside the parentheses, which would be 2 to the negative x, okay? Is that the same thing as 1/2 to the x? It is, because 1/2 is the same thing as 2 to the negative 1. So I can rewrite this as 2 to the negative 1 to the x, right? So because when you raise a power to a power, you would multiply the exponent. So negative 1 times x would give me the negative x. And then 2 to the negative 1 is the same thing as 1/2. So this is the same thing as 1/2 to the x. Number 4, find formulas for the following transformations of the exponential function 2 to the x. So the parent function is shown lightly or in red when you're looking at it in color. So the red graph is 2 to the x, and we want to find a formula for the function graphed in black. And the hint says check to see if the horizontal asymptote has shifted. So in this first one, there's a horizontal asymptote at the x-axis, and it appears that the whole asymptote has moved up for the black graph. So it looks like it's up 3 units from where it was. So the y-intercept moved up 3 units, this 0.12 moved up 3 units, and the whole asymptote moved up 3 units. So this is f of x, or 2 to the x, plus 3. To shift the whole thing up 3 units. Now when I look at the next one, 2 to the x is graphed in red, and you might initially say, oh, we shifted up 2, because we went from 0, 1 to 0, 3, up 2, but the asymptote didn't change. So the asymptote was at 0, and it's still at 0, okay? So this is not a shift. it could be a stretch because if you multiply 0 by something, it stays 0. So let's see, what do you multiply 1 by to make 3? You multiply by 3, right? So 0, 1 goes to 0, 3. 1, 2, if this is a stretch, then 1, 2 should go to 1, 6. You should multiply this 2 by 3, just like we multiplied this 1 by 3 to get 3. So 2 times 3 is 6. So this looks like a vertical stretch by a factor of 3. So this is going to be 3 times 2 to the x. Be careful not to write this as 6 to the x, okay? Because you have to do the exponent before you can do the multiplication. And since we don't know the exponent, it's a variable, we can't do the multiplication. Okay, so just be careful. This does not equal 6 to the x. Okay, for number 5, I want to find an exponential function b to the x whose graph is shown. So basically, I just need to know what b is, the multiplication factor, the growth factor. And I'll have answered the question. So I have a little blank table here. I'm going to put in some points. So I have 0, 1, 1, 5, and 2, 25. Okay, so what are you multiplying by to get from 1 to 5 and from 5 to 25? This is times 5, and then 5 to 25 is also times 5. So my growth factor is 5. So my function is f of x equals 5 to the x. Number 6, the value of an investment v of t in year t is given by v of t equals 3,500 times 1.0125 to the t. Describe this investment in words. Well, 3,500 is our initial investment, also sometimes called the principal, and 1.0125 is our growth factor. We have to subtract 1 and change it to a percent to get our percent interest. So this is a $3,500 investment. Okay, and then growth factor is 1.0125, which tells us that interest rate is 0.0125, which is the same thing as 1.25%. The annual inflation rate is 2.1% per year. You can tell that this was written a couple of years ago because it's much higher than that now. And the cost of a movie ticket is $9.50. Find an exponential function for the price of the ticket P of t years from now, assuming ticket prices increase at the rate of inflation. So, and that inflation stays constant. So that is an assumption that may not be true, as we have seen. But let's go ahead and answer the question. So P of t is my function. The initial cost of the movie ticket is $9.50. And it's growing at an interest rate of 2.1%, so let's change that to a growth factor. First, you take the 2.1% and you make it a decimal by moving the decimal point 2 places to the left, and then you add 1.021%. Or sorry, 1.021 is the growth factor. You multiply by that every year for t years. Number 8, an irrational number, symbolized by the letter e, appears as the base in applied exponential functions so often that we call it the natural base, and the function f of x equals e to the x is called the natural exponential function. The number e is defined as the value that 1 plus 1 over n to the n approaches as n gets larger and larger. So we're going to use our calculator to investigate the value of e. So I'm going to evaluate 1 plus 1 over x to the x for some different x values. So I'm going to start with 10. So I'm evaluating 1 plus 1 over 10 to the 10th. Okay, and that comes out to approximately 2.59. Okay, then I'm going to do the same thing for 100. 1 plus 1 over 100 to the 100. And that comes out to 2.70 approximately. And then we're going to do it with 1,000. And you get 2.72. And then do it with 10,000. And you get 2.72. Okay, and then if you keep going bigger and bigger and bigger, it keeps rounding to 2.72. You'll see that the final decimals do continue to change, which is why this is defined as the limit. But if you round to 2 decimal places, you keep getting about 2.72 or 2.718. Okay, so E is about 2.72. So here's a graph of e to the x. We want to use the above formula, e to the x, in our calculator to find f of 0, f of 1, and f of 2. So e to the 0 is going to be 1, because anything to the 0 is 1. F of 1 would be e to the first, and anything to the first is that thing, which is e, and that's approximately 2.72. And then f of 2 would be e squared, which is approximately 7.39. And we're going to confirm our answers. So when f of 0 is 1, so that means the point 0, 1 should be on the graph, and it is. F of 1 is 2.72. That means that 1 comma 2.72 should be on the graph, and that looks right because that point is like not quite at 3. And then f of 2 equals 7.39 means the point 2 comma 7.39 should be on the graph. And that does look like it's at about at least around 7. So we confirmed. Number 9, match each of the following equations with one of the graphs below. The parent function f of x equals e to the x is shown lightly in each graph. Okay, so the parent function is e to the x. We want to match it with one of these formulas. So it might be helpful to jot down what each of these transformations represent before we start looking at the graphs. So this first one, it has a +2 in the exponent. So with the x. So this is a horizontal shift left 2. Okay, and 2 times e to the x, it's multiplication, which means it's a stretch or a shrink. It is outside the function, which means it is vertical. So this is a vertical stretch times 2. E to the x minus 1. So this is addition or subtraction, which means it's a shift. The minus 1 is outside of the function. It's not up in the exponent like it was over here. It's outside. So this is a shift down 1. And then 1/2 times e to the x. This is multiplication. It's outside the function. So this is a vertical shrink times 1/2. Okay, so let's see if we can, the vertical shift is going to be the easiest one to identify because the asymptote is going to move. So here, the asymptote for the parent and the transformed function is both the x-axis for both, x-axis for both. But here, in this last one, you can see that the original function, the parent function, has the x-axis as its asymptote, but the transformed function has as its asymptote x equals -1. The horizontal asymptote has moved down 1, so this is C, e to the x minus 1. Okay, so let's look at my vertical stretches. So the original function should have a y-intercept of 1, 1. Okay. When we do a vertical stretch, the y-intercept is going to double. So instead of being at 1, it's going to be at 2. So this has a y-intercept of 2. This has a y-intercept of a half. And this has a y-intercept of 7. So one of those is double the original y-intercept, and it's this one. The y-intercept was 1. It doubles and becomes 2. So this is my vertical stretch. Y equals 2e to the x, or equation B. Okay, then my vertical shrink, my y-intercept should have, right? Every point should have, but the y-intercept is a nice one to follow. So the y-intercept of the original was at 1, and then this one has a y-intercept that's half of that at a half. So this is y equals 1/2 to the x, or equation D, which means that this one would have to be the left 2, e to the x plus 2. Let's verify. So my original function had a y-intercept of 1. Okay, 0, 1 was on the original graph. If I move that point left 2, 1, 2, I do land on the new function, the transformed function. So this is my left 2, y equals e to the x plus 2, which is equation A.